All right, are we ready to get started? We're finishing up. Here we go. We're finishing up chapter 4 today, right? And then starting chapter 6 on Thursday, and then what? A spring break, is that correct? It's break for sure. It is break. Okay, just making sure. Here we go. You ready? You guys are so young. You guys are so young that you don't even know what the word Chernobyl means. Nobody's even listening. You know we're recording this, right? Chernobyl? You're so young you don't even know what the word Chernobyl means. Exactly.
Like the place in
the place.
In Ukraine?
Thank you.
It's the place in Russia.
Ukraine.
Ukraine, Russia. Same thing. Okay.
Well, back when it was the USSR.
But why is it such a famous place?
Reactor meltdown.
It was a disaster there.
That's right, because of a nuclear meltdown there, and you're too young to remember, and yet we have countries about to throw nuke bombs at each other, and you guys are in class going, nothing to worry about. It won't affect us. That's where you're wrong. It will affect the whole world, and you should be worried. And if I'm trying to make you worried, I want you to lose sleep. That's an exaggeration. I don't want you to lose sleep. I'm losing enough for all of us.
Only if
you ready?
Only if you lose as much hair as we lose sleep. I'm losing here.
Thank you. You ready? This owner of the custom wheels has just received 1,000 standard wheels and 1,250 deluxe wheels. And then for 1 month, and then next month another 800 standard wheels and 15 deluxe wheels. Real quick, our objective is to do everything we can to not have this order on back order, to fulfill the customer's order. So we got to figure out if we can do it, and at the same time not lose money on what we just bid on to get this order. And what we're going to find out is we may have to pay overtime to fulfill the order in these 2 months, which costs so much more. You know, are we truly going to make money off it? So here's the deal: the cost of making the standard wheels, however many we're going to make in the first month and second month, is going to be $10 each out of our costs. And it's going to cost us $16, to do the deluxe wheels. If we get into overtime, the costs are 50% higher. Tell me how much it would cost to make a standard wheel. $15. How much to make a deluxe? 24. Half a 10 is 5, add 5 to it, 15. Half of 16 is 8, add 8 to it is $24. Our cost goes up significantly if we get into overtime to fill this order. There's 1,000 hours of regular time and 500 hours of overtime available each month. So if we can't fit this order in standard time and we go into overtime, and then if we can't fit the order in overtime, we got to figure something out. That's where we start looking for a subcontractor, because we need to fill the order. We made a bid on this order as if we can fill it, and by putting them on back order, we will never see an order from this customer again. You realize that's the reality? Probably never, no matter how good our price is, because we didn't make them all. We didn't fulfill it. So here's our limitations in hours. Here's our costs. Here's our needs. Here's what makes this one hard. If you decide there's a way, let's say, to avoid overtime in the following month, you may make extra in the first month. And if you make extra standard wheels, that costs $2 to leave it in inventory for the following month's order. And the same with deluxe wheels, some $2 for each of them that are left in inventory. So you could have, hey, we're going to produce extra in the first month because we have some time available in standard time to avoid some overtime maybe the following month. It would be worth the $2 to put it in inventory to carry it to the following month to avoid some overtime, right? Because the overtime cost, even if it was just standard wheels, is an extra $5. $2 is less than half that. It's obviously the best decision. But that's the thing. As a manager, look at the decisions you have to make. And each decision has to be a variable. This should help you. How many decisions do you see? 4. No. 8 is all you see. But there are 10. Yeah. What are the other 2 decisions? Wait, I heard it. If we put it in storage, inventory. There's got to be a variable that represents how many we're deciding to make extra and put into storage of standard wheels, and a variable that will determine, that we have to determine how many we're gonna make extra and put into storage of deluxe wheels. Those are the extra two variables. So now we're at 8 to 10 variables altogether. And if you were doing this as a homework problem, you said X1, X2, X3, X4, X5, X6, X7, X8, that's fine. As long as you defined X1 is the amount we're gonna make during standard regular time the first month. X2 is the amount of standard wheels we're making the first month during overtime. As long as you're defining them, I don't care what letters you use. You can use any letter you want. It's the definitions that will make sense to me as I'm looking over the problem. This happens to be deluxe wheels during regular hours first month, deluxe wheels during overtime first month, and then you have all the same in the second month, overtime and regular time. There's our variables, plus inventory regular, inventory deluxe. And that's the decision. How many are we going to schedule? Production's about to start next week, or we got 2 months. We have to plan ahead and make sure to fill the order. So we're going to line this up as an objective function and constraints. Real quick, before I move to the next slide, I know somebody printed, but what do you think the objectives related to? Profit, cost, what?
Profit.
Profit? Where is it telling us how much profit we're making in the store?
Oh. Big cost.
Cost. It is telling us how much it's costing. Right here. $10. So this is probably what we're trying to minimize. Thank you. Now this I skipped. For every regular standard wheel we make, it takes a half hour. For every deluxe wheel, it takes 6/10 of an hour. There's the time it takes for the wheels. However many we're going to make, there's only 1,000 hours of regular hours available, and standard wheels is using up a half hour of it. Deluxe wheels are using 6/10 of it, and however many the combination is, it can't go over 1,000, or if it does, we go into overtime. Standard hours, there's only 1,000, right? I got that right? Less than, greater than, or equal to 1,000. I heard it. Less than, equal to, because we cannot go over 1,000. 500 hours, all we have of overtime. Less than, greater than, equal to 500. Less than, equal, 500. This is month 1. Month 2, 1,000 hours. 500 hours. But there's limitations for each of the 2 months, month 1 and month 2. What else do we have for limitations? Here we have our cost, our objective function. Let's see, let me go to the variables. You said, I'm going way down here. I want people to be able to see it though. Min, going one variable at a time. SR1 represents a standard wheel made during regular time during the first month, which will cost us how much money? How much are standard wheels in the first month? $10. 10 S, I already forgot. R1. R1 plus, let's go with SO1. What number goes with that? 15. SO1 plus, I'm going down now to DR1. 16 deluxe wheel during regular hours plus 24 deluxe wheels during overtime first month. And then we got to repeat these numbers for the second month, right? Plus 10 SR2 plus 15 SO2 plus 16 deluxe regular time month 2 plus 24 deluxe overtime month 2 plus what now? The storage, but we got storage of standard, storage of deluxe, $2 for every standard wheel we put into inventory, SI, plus $2 for every deluxe wheel we put in inventory, DI, is also a cost we want to include in there, and that's our 10 variables. There's the objective function. I just applied the cost from the previous slide to each one of the variables, and then I knew that these two variables were the other ones that will represent inventory, and that the cost was $2. Let's get now, this is where it's going to get hard, because you have to take that inventory into consideration in all of these, which, you got to try to imagine this. You got to say, pretend as if this is a real problem in front of you, and your logical mind will come through with what will be, how do you represent that? I don't want to show you. Yeah, good. Here's our objective function, $10, 15, 10, 15, 16, 24, 16, 24, 2 and 2. Right? You ready? Let's look at it. It says, however many standard wheels we make during regular time and however many standard wheels we make during overtime, we've got to make 1,000 of them. We have to fulfill, that's the first part of the order. I want to make sure, hang on a minute. I put the hours there, but there's also, we want to fulfill, what is that, 1,000, and then how many, 1,250, and then what about the second month? I forgot about these. 800, right? And, huh? And 1,500. So we have these. We're going to meet these orders. Now let's go back. Here we go. Yes, we got to make at least 1,000 of the standard wheels in the first month. There's going to be regular time and overtime. However many we make during that first month, it's got to be 1,000 plus, if we decide to make extra, that's the amount going into inventory for standard wheels. Now we got to get this variable to the other side, but this is the logic right there. Same with deluxe wheels, same type of logic. We need at least 1,250 of those. So deluxe wheels during regular time, deluxe wheels during overtime, we got to meet the order at 1,250, and if we decide to make extra, it would be, okay, we're making 1,250 plus however many we're going to put in inventory. Use algebra to get these variables to the other side, which means subtract it from both sides. This all turns into standard wheels overtime, minus the amount we're putting in inventory is going to equal 1,000 to meet that order. Same with here, the amount going into inventory with deluxe. We've got to subtract the deluxe inventory on both sides. So, the deluxe wheels during regular time, deluxe wheels during overtime. If we make extra, they got to come to 1,250. The extra is the part going in inventory. Now we carry this inventory to the following month, and we got to fulfill the orders of 800 and 1,500. So the 800 is going to be, hey, we're going to make standard wheels during the second month in regular time. We might make standard wheels in overtime, even though we're trying to avoid it. And we need to have at least 800, unless we made extra last month. We can subtract that from the 800 because really that's all we need. Now we use algebra and put that SI on the other side. So, however many we made last month, and however many we're about to make in the second month, are going to equal the 800. Same takes place with the deluxe wheels in the second month. Deluxe wheels during regular time, deluxe wheels during overtime. We got to meet the order of 1,500, but we get to subtract however many we made extra from the previous month and put in inventory. Then we use algebra.
So I must have missed it. I thought both orders were due at the end of the second
No,
month.
no.
So they're both due at the end of each of the respective months.
No, they're each doing their corresponding month.
Okay.
At the end of the first month is that 1,000 and 1,250, and then at the end of the second month, another 800 and 1,500.
Okay.
So we got to fill that first order, and as long as we're not getting into overtime, we're probably going to make extra to carry over to the following month if we foresee that there's going to be overtime in the second month to avoid it. But you know what? As I look at this, the only reason we might have overtime in the second month is because of that 1,500 deluxe. It's actually less standard wheels than the previous month, right? We'll see. We have to fulfill these orders, equal, which are those first four we just saw. Again, here is fulfilling the orders. Now, we only have so much time available, right? So here's our time. 1,000 hours are available in regular time first month, 500 overtime the first month, 1,000 hours are available the second month, 500 hours overtime the second month. It takes a half an hour for every standard wheel we're making during regular time the first month, and 6/10 of an hour for every deluxe wheel during regular time. Whatever combination we're going to make, it can't use up more than 1,000 hours because all we have. Same with overtime. If we end up making any in overtime, it takes a half hour for every standard wheel, 6/10 for every deluxe wheel, and we can't go over the 500. Second month, 1,000 and 500 again. Same exact numbers, but different variables because it's month 2, month 2, month 2, month 2. Regular, standard regular, deluxe regular, standard overtime, deluxe overtime. I think that's it. That is it. Those are 1, 2, 3, 4, 5, 6, 7, 8 constraints, 10 variables, minimize objective function. What is this one? Right here. Here we go. I set this up. I just took the generic spreadsheets posted on Blackboard. Matter of fact, this one is also. And I just went ahead and I added some columns at the end. I changed the variable names. And the hardest part when you go and use a spreadsheet that's there, but didn't have as many variables as the one you're about to do is, you've got to make sure that the equations that are in the subjective function cell and the left-hand side of those constraint equations are now including these additional optimal answers as part of the equation. Let me make sure you see this. Notice that this objective function is going all the way from E, all the way to N. E14, E18, F14, 18, G14, 18, H, I, J. But before, when I just got this off of Blackboard, it went only to I or J, so I had to increase the formula. Also, the left-hand side of the constraints. This originally only went to maybe J or I. So you got to go, okay, this is constraint 1, which is using row 6, E6 times the optimal solution in E18. F6, 18, G6, 18, all the way to N. Constraint 2 is going to be using row 7. E7 times E18, F7, 18, G, so on. That's the only thing. I had to make sure those formulas included the new columns that I created. Okay, you ready? Now, up here real quick. For some reason, I had all these blanks where these zeros are. And when I took the spreadsheet off of Blackboard that you may grab, for some reason it won't work. It's giving you some error message, and then I threw in some zeros where the blanks were, and it works great. So I just want you to be aware that that's a possibly could happen to you too. So throw some zeros in. It will say invalid values and things like that. And it didn't make sense because all the numbers are in there correctly. It just needed some zeros. Why Excel does that? Look at it. I didn't have to put zeros here, just at these first 4. Anyway, instead of correcting it, just threw some zeros in, and it works perfect. These are all your constraints. Ones are underneath the variables that are part of that constraint. Here's your optimal solution. Here it is. You ready? I'm going to, which tab am I going to? Data? All right. Then which one? Solver. Let's go with, hey, get these out of here. Hey, that's too late. All right. The objective function goes in that first one, which is right there at E20. This is a minimize. Changing variable cells all the way from E18 to N18. Here's my constraints. The first 4 were equal, and I could have put them together, but they were already there. Then I had to add these. These 4 are less than equals, and I bunched them together. That box is checked, simplex, ready to go. My question for you is, how are we using overtime in the first month?
For the standards.
You ready? Terry, why do you say no? How do you know?
No, it's just like I don't know.
Oh, okay. You're waiting. All right, are we using overtime in the first month?
Yes.
We are. You see it? This variable represents overtime in the first month, and it looks like we're making 500 standard wheels in the first month in overtime. Unavoidable. Here's overtime. Oh, that's month 2. Here's overtime deluxe wheels first month. We are using. What about month 2? Are we using any overtime month 2?
Yes.
Look at that. Where is it? Standard wheels overtime month 2, 600. And where's deluxe wheels overtime? Deluxe wheels overtime month 2, 0. Are we putting any in inventory?
No.
Now, does that make sense? Yeah. Do you see this? Overtime. Where's month 1? Right there. Oh, I see. We can't avoid that even if we were. But where's month 2 overtime? So what's happening here, where's overtime month 2? That's 600 right there. Basically saying there's only 500 hours of overtime. So my guess is this is using 250 of the hours, right? Half hour for each one. But there's 500 hours. So couldn't we have avoided some of this overtime to increase, if we increase that? Oh, yeah, duh, I don't know. Let's compare this to the answer on the PowerPoint. My question for you is, whoops, again. Are there any wheels being put in inventory according to this output? Anybody see it?
Where's the inventory at?
Right here.
No.
Standard wheels inventory, deluxe inventory. Right? You gotta be ready to answer these questions. We're gonna fulfill these orders, we're using inventory for some reason, we're using overtime for some reason, we're not putting it in inventory. This is the lowest we can get our cost, which is how much? For all of these wheels, how much is the cost? That's right, $67,500 is going to be our cost of sales for the production of these items. And that's the lowest we can get it. For some reason, even using inventory can't get it lower, for whatever reason it may be. I just want to make sure this one, where is it, right here? What is our total cost here?
Same.
You see it? That's right. Same number. Oh, here we go. Let's do this. How many non-binding constraints do you see? Non-binding constraints. I heard it. That's it? You're saying out of 8 constraints, 6 are binding? Is that true? Name one that's not binding. How's that? 6 and 8. Is that what I hear? Yep. If those who don't get this, they're looking at the left-hand side and comparing it to the right-hand side, and if it's not the same, then it's not binding. If it's the same, that means there was 0 slack or surplus. This one's not binding, so is there slack or surplus on this constraint right here? And how much? 250 slack. How'd you know it's slack? Because the constraint's original is? Less than equal. Good. Constraint 3, slack or surplus? I'm sorry, constraint 8. Slack and how much? 200. You got it. 2 non-binding constraints. All right. Let's keep going. Hang on, I gotta find it. Here we go. You ready? Where's my finance majors? Hit them outside. You ready? Okay. Whoops. Can't see it. The employee credit union at State University is planning the allocation of funds for the upcoming year. The credit union makes 4 types of loans to its members. In addition, the credit union invests in some risk-free securities to stabilize income. The various revenue products, or loans, it's revenue for the bank, but it's a loan for the customers, are as follows, including the risk-free security to stabilize the various products together with their annual rates of return. So if we loan out some automobile loans, we're going to average about 8% return on that investment. Furniture loans, 10%. Now, I want you to make sure you understand how a credit union works. The credit union has members who are depositing money in the certificate of deposits, the high-yield savings account, and they're trying to make a little money on their money and keep it safe and insured in case we have a meltdown of some kind or whatever, right? At the same time, the credit union's taking their money, all these members who are depositing, and say, hey, let's lend it out to these members over here. They're paying these members 3% maybe, and they're lending it out at these percentages, keeping the difference. The spread. That's how banks and credit unions and financial institutions make money, on the spread. If they can borrow it for less and then lend it out for more, it's not even their money, and they keep the difference. And now, the reason I'm bringing this up is because if you're going to go to work for a business, and many of you are, that has, let's say, 4 million, 5, 10 million in sales or more, that business has learned the art of leverage. And the art of leverage is where this business is constantly looking through their financial institutions that they do business with to borrow money. And if the interest rate, because they see opportunities to borrow at one rate and invest it in either expanding their business, buying another, doing something, a way for them to make money on that money at a higher rate than what it costs to borrow it, called leverage. All right? So, you have to decide how much, and how much money we're talking about. How this $2 million is available is going to be spread out as far as what you're gonna do with it, as far as lending it out. That's the decision. But there's some restraints to this decision. Matter of fact, you're being told that you need to earn as much on that $2 million with these options as possible. Your first instinct is to say, I'm gonna go ahead and take a bunch of it and do what with it? Signature loans. Signature loans. Now, not all of you are finance majors, so I don't expect you to know this, but signature loans are considered very risky because you're asking the person to sign on the dotted line and you're going to lend them thousands of dollars, and if they default, nothing has been put up as collateral but the reputation in that signature. And you get to sue, the credit union will sue them, but they don't get to go and grab anything. Not a car, not a house, not a motorcycle, nothing. It's a signature loan. That's why it's a higher rate, because there's more risk involved. And there's no way we can take all $2 million and just take that much risk to everybody and say, here you go, just sign on the dotted line, don't worry, you don't pay it back. Okay, claim bankruptcy, and we can't even get it out of the court. That's the risk. That's the risk. All right? Now, here's some rules. The state laws and the credit union policies impose the following restrictions, though, in your decisions on how you're going to lend this money out or invest it. And first, risk-free securities, right here, risk-free securities may not exceed 30% of the total funds available for investment. Now, this is one of those problems where I said to you last week, you should write out your equation exactly as it reads and then use algebra to straighten it out. So what I'm going to do is I'm going to assign some variables. Let's just go x1, x2, x3, x4, x5, okay? This seems to be the decision. Do you agree? What we're going to do with the $2 million. But now I'm going to use the variables I just said and write this sentence out just as it reads. Risk-free securities, what is that, x1, x2, x3, x4, or x5? x5, risk-free securities, may not exceed, help me, less than equal
30%.
less than equal 30%, I'm just writing it as a decimal because I know I got some math ahead of me, 30% of the total funds available to invest, which is $2 million. How's that? There doesn't even need to be algebra done. I thought there'd be, usually there's some variables on the right, you gotta go ahead and subtract or add or something, get them to the left. In this case, we'll just multiply that and make that x5 less than equal to 600,000. Is that right? Yeah. Right? Okay. We'll recognize this pen is running out. Next one says, signature loans may not exceed 10% of the funds invested in all loans, automobile, furniture, other secured, and signature loans. Just the loans, not this risk-free security, just the loans. So be careful. Are you ready? Signature loans. Give me the variable. X4 may not exceed less than equal to, what's that, 10%? 0.1 of times. This is the biggest part, everybody makes a mistake right there. Of means times. Multiply. 10% of, 30% of. Multiply 10% of, multiply the funds invested in loans. I gotta write something between these parentheses that represent all the money that will happen to be invested in the loans, not the risk-free securities. You ready? How's that? This represents all the money being invested in the loans, and I left X5 off because that's not the stipulation. It says risk-free securities isn't even part of this. Now I gotta use algebra. I gotta get the variables off the right to the left. So this is gonna be X4 less than equal to 0.1 X1 plus 0.1 X2 plus 0.1 X3 plus 0.1 X4. Now I'm subtracting each of these on both sides, which is going to affect this one. I'm going to start with X1, negative, hang on. You guys know where I'm going? Negative 0.1 X1 minus 0.1 X2 minus 0.1 x3, help me out, minus or plus? Huh? Plus 0.9 x4, 1 x4, we're subtracting 0.1 on both sides, we got left a positive 0.9, less than equal to what? What's left on the right side? That's it. There's that constraint. Let's keep going. Furniture loans plus other secured loans, let's just stop right there. Furniture loans, variable, help me. X2 plus, you know how to write that, plus. Other secured loans, what? X3. X2 plus X3 may not exceed, here we go. Let's take this over here. May not exceed what?
Less than or equal to x1.
So, what were the variables? X3 plus X4, is that true?
x3.
Oh, X2.
x2 plus
X2 plus X3 may not exceed.
x1.
Exceed automobile loans. X1, use algebra, subtract X1 on both sides. You get negative X1, or I could have, you don't have to have it in numerical order, I just have it. Negative X1 plus X2 plus X3 less than equal to 0. Only a number on one side, all the variables on the other side. We wrote it just like it read. One more. Other secured loans plus signature loans. Other secured loans
x3.
plus signature loans.
x4.
X4. Other secured loans plus signature loans may not exceed.
x5.
No. Less than equal, thank you. The funds invested in risk-free securities now.
x5.
Less than equal to X5. We subtract X5 on both sides. Subtract X5, subtract X5. We get X3 plus X4 to 4, right? Minus X5 less than equal to 0. Is that it? Write a linear program. This is a perfect example of what you should expect on the quiz. This really isn't that hard. It's just taking as you read it, write it out, and apply some algebra. This is posted already, I'm almost sure, including the answer we just did. X1, X2, X3, X4. Oh, we got to do the objective function. Darn.
But you also need to do about the 2 million too, right?
Oh, and the $2 million. Here's the objective. We want to maximize the percent that it said we were going to gain from each of these. This is basically saying, hey, we want to put as much in the 12% as possible, then put some in the 11, 10, but stay within these rules, these restrictions. Let's do the 2 million real quick. So basically the 2 million would be X1 plus X2 plus X3 plus X4 plus X5. Is this less than equal or equal?
Equal.
Really? Let's look at this. If we have 10 cents left over after we come up with our numbers, do we have somewhere we could put it? Where would you put the 10 cents if you had 10 cents left over? $1. Now, of most financial questions, there's like an option which would be equivalent to a checking account or a savings account or a money market fund, where you can put just $1 in. But in this one, I don't see any of these that if you have money left over, I don't know if you could. So just to be safe, I put less than equal 2 million, and then I might see what happens if we do make it equal. But if there's like odd numbers taking place and there's $1 left over, I want to have the option of not investing in any of these, only because it wouldn't make sense. There's nobody you can lend $1 to at a credit with any of these options. Let me see what the answer is. And again, this is the book's answer, by the way. Equals. Equals. All right, let's switch it. I'm still going. Maybe we'll get the same answer anyway. Let's check. We forget anything else? We got the 600,000. X5 less than 600,000. Here it is, but we apply algebra, so it becomes this. 0.1, we got this. 0.1, X1, X2, X3 less than or equal 0. This one, X2, becomes negative X1 minus plus X2 plus X3 less than 0. This one ends up becoming X3, X4 minus X5, 0. And then we have the 2 million. That answer is posted. Let's solve it. And here we go. Is this it right here? 8%, 10%, 11%, 12%, 9%, 600,000, 2 million. This is it, right here. Maximize. Let's look down here. Check out. Here's where the important part is, that these formulas are correct. Is it using all the way from E to I? Sure enough. Left-hand side of these constraints. Is it using from E to I? Again, let's make sure. Looks like they all are. What happened there? All right? E to I on all these?
Yep.
All right. Let's solve it. Data. Solver. Real quick. All right, E18. Max. E16 through I16. Is that where the optimal solution is going to be placed? Constraints. Are all of them less than equal except for the last one? E22 through E25 less than equal, J23 through J25. And then the last one's an equal. E26 equals J26. Box is checked, simplex method. How much is going into that signature loan, which is the most risk possible? What variable represents signature loan? I think I got hit okay. How much money are we putting into signature loan money? Wait, what happened? What is this?
It always does that.
Why does it do that? All right, how much is going into the signature loan? No. I wish that were 140,000. It is. Just check. Oh, it's 1,400,000. 140,000 going out to this risky investment. 600,000 going into the risk-free, money market fund savings account. And then what is it? Automobile and furniture and whatever the other loan was right there spread across. The most we can make and stay within these restrictions is how much money out of that $2 million. How much are we going to make off it? How much? Right there, $188,800. And that's the most you can make. There may be a combination we could do that still stays in these restrictions, but this won't make us any more money than this. That's the most we can make. How many non-binding constraints do you see? 3 non-binding constraints? Where? 0. They're all binding. This is all intersecting right at that answer. Right there. There's no difference between the left and right hand side on these with this answer. Okay? Are we ready? Okay. This is the end of the foundation of linear programming, which all these other chapters do refer back to linear programming, but they're all separate jobs of their own. Now we have a choice to